Welcome to Vtcodex. Today, we're breaking down how to build decision-making into your Python scripts using conditional statements. If you're ready to start building smarter code, hit subscribe and share this with your fellow developers. Every day, you make hundreds of decisions using a basic logical filter. If you're hungry, you order food. If you're not, you don't. Your brain runs this conditional check automatically. To give your computer that same decision-making power, we use an if statement. This code asks the user for their age. By wrapping the input in this int function, we convert the text they type into an integer number. Then we set up our condition. If the age is greater than 18, the program prints, "You can drive." This process formalizes the mental shortcuts you use every day into a structured set of instructions. Instead of a linear script, your code gains the ability to react to changing information. Look closely at that previous block. What if the user is exactly 18 or younger? The condition fails and nothing happens. To handle the alternative scenario, we introduce the else block. If the first condition evaluates to false, the program automatically falls back to the second set of instructions. Now, look at the end of the if and else lines. Those colons are mandatory. They signal to Python that a new block of logic is about to start. Leave them out, and your program crashes immediately. Directly beneath those colons is the most common trap for beginners. You must provide exactly 4 spaces of indentation before the print statement. If everything is pushed completely to the left edge, Python will throw an indentation error and refuse to run. Other programming languages use curly brackets to group code together. Python relies on physical white space to define strict structural boundaries. The empty spaces tell the machine exactly which commands belong to which condition. To build more complex logic, we need conditional operators, like less than, greater than, or equal to. Pay close attention to the difference between a single equal sign and a double equal sign. A single equal sign assigns a value to a variable. A double equal sign actually checks if 2 values are identical. When you have more than 2 possibilities, you use an elif ladder. Elif stands for else if. This code checks if a number is negative. If it's not, it moves down the ladder to check if the number is exactly 0. Finally, if both conditions fail, the else catches everything remaining, meaning the number must be positive. Python executes this ladder using a lazy behavior called short-circuiting. The moment it finds a condition that evaluates to true, it executes that specific block, then jumps completely out of the ladder. It ignores all subsequent checks to save processing power. Take a moment to apply this. Pause the video and write your own program. Set a budget variable. If it's greater than 500, print buy pizza. If it's greater than 200, print buy burger. Otherwise, print save money. Here is the code for that problem. Check your logic against the screen. Ensure your indentation is correct and your colons are in place. Because Python stops reading the moment it finds a true statement, the sequence of your elif ladder dictates the outcome. If you put greater than 200 at the very top, an input of 600 would trigger the burger block and skip the pizza check entirely. You can also place an if statement completely inside another if statement. This technique is called nesting, and it allows you to build multi-layered decision trees. Tracing the execution flow, the program evaluates the outer condition first. It only moves to the inner condition, the second level of indentation, if that first check passes. If the initial number is negative, it skips the entire inner block and drops straight to the bottom else. To keep your programs running smoothly, review this cheat sheet. Remember your colons, clearly distinguish equality from assignment, and double-check your indentation levels. If you found this lesson helpful, subscribe to Vtcodex and leave your questions in the comments. By mastering conditionals and their strict structural boundaries, you give your code the ability to evaluate data and change its behavior on the fly. You turn a static list of commands into a dynamic program capable of reacting to the real world.